Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Scientists from an international collaboration have found evidence of alpha particles at the surface of neutron-rich heavy nuclei, providing new insights into the structure of neutron stars, as well as the process of alpha decay. Neutron stars are amongst the most mysterious objects in our universe. They contain extremely dense matter that is radically different from the ordinary matter surrounding us, being composed almost entirely of neutrons rather than atoms. However, in the nucleus at the center of normal atoms, matter exists at similar densities. Understanding the nature of matter at such extremes is important for our understanding of neutron stars, as well as the beginning, workings, and final fate of the universe, says Junki Tanaka, one of the leaders of the study. Intriguingly, despite the vast difference in size and mass, the tiny atomic nuclei found on Earth and the enigmatic neutron star are actually governed by the same type of interactions, says Zihong Yang, also a co-corresponding author of the paper. This connection has been well established by scientists through the nuclear equation of state, EOS, which describes the relation between the density and the pressure of nuclear matter. In the current finding, published in Science, the research team led by scientists from the Riken-Nishina Center for Accelerator-Based Science, TU Darmstadt, and the Research Center for Nuclear Physics RCNP, examined tin nuclei, and found evidence of alpha clusters, groups of 2 protons and T. For the experiments, the group examined a series of neutron-rich isotopes of tin ranging from tin-112, which has only 62 neutrons, to tin-124, which has 74 neutrons and thus has a much thicker neutron skin. They used a method to deliberately knock out alpha particles from the nuclei by bombarding them with protons at the Research Center for Nuclear Physics RCNP, at Osaka University, and then examined how frequently they were able to observe alpha particles in progressively heavier isotopes. They identified the clusters in the very surface region of neutron-rich tin atomic nuclei, implying that the so-called neutron skin is not purely neutron matter as its name implies, but also includes alpha clusters. Importantly, they also discovered that the effective number of alpha clusters, the probability of finding alpha clusters in nuclei, decreased gradually along with the number of neutrons, and theorized that this is due to the interplay between alpha cluster formation and the thickness of the. This finding has important implications for our understanding of nuclear EOS and neutron stars. In the near future, more and more accurate data on the bulk properties, mass and radius, of neutron stars will be available from electromagnetic and gravitational wave observations. The present work is also a key step towards a full understanding of alpha decay, a type of radioactive decay in which an atomic nucleus spontaneously emits an alpha particle. About 90 years ago, physicist George Gamow famously proposed that alpha decay takes place due to the quantum tunneling of preformed alpha particles or clusters. However, though the theory was generally accepted, it was never shown conclusively that such clusters actually existed in heavy atoms. The finding of the current work that alpha clusters exist at the surface of heavy nuclei could provide an answer to the question about the origin of alpha particles in alpha decay. In the future, the group plans to work with high-energy accelerators such as the ReBeam factory at Riken and GSI Fair, a new accelerator facility being built in Germany to do studies using alpha radioactive isotopes. Story source: materials provided by Riken. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.